Welcome to today's lesson on analysing the results of culturing bacteria. In this lesson, we will explore how to interpret the outcomes of bacterial cultures, with a specific focus on understanding the size of bacterial colonies. In today's lesson, you will learn how to calculate the size of bacterial colonies and the zone of inhibition, as well as how to estimate the number of bacteria in a population after a certain period of time. This analysis is crucial for various applications, including identifying bacterial strains and evaluating the effectiveness of antibiotics and antiseptics. So far, you have learned how to culture bacteria in the laboratory using aseptic techniques. You have also tested the effects of different antibiotics and antiseptics on bacterial growth. This foundational knowledge is essential as it sets the stage for today's lesson, where we will build on these skills to analyse and interpret the results of bacterial cultures. It allows us to differentiate between types of bacteria, determine the efficacy of antimicrobial agents, and make informed decisions about treating bacterial infections. This insight is crucial for microbiologists, healthcare professionals, and researchers who work to control and prevent bacterial diseases. Let's get started. When you culture bacteria, they often form visible colonies on an agar plate. To measure the size of these colonies, you need to calculate their cross-sectional area. Since most colonies are roughly circular, you can use the formula for the area of a circle, area equals pi r squared, where pi roughly equals 3.14 and r equals the radius of the circle in millimeters or centimeters. Now, let's go through a step-by-step approach to measuring the size of a bacterial colony. In our first step, we need to measure the diameter of the colony using a ruler. In our example, we have a diameter of 6 centimeters. After we have taken this measurement, we can calculate the radius by dividing the diameter by 2. So we have a radius of 3 centimeters. Next, we need to apply the formula for the area of a circle. We first square the radius of 3 centimeters to get 9 centimeters squared, and then multiply this by 3.14 for pi. So we get a final answer of 28.26 centimeters squared. Now that we are familiar with the steps, let's take a look at another example. If a bacterial colony has a diameter of 4 millimeters, what is its area? If a bacterial colony has a diameter of 4 millimeters, we can calculate the radius by dividing the diameter by 2. In this case, 4 millimeters divided by 2 gives us a radius of 2 millimeters. Now, we can use this information to calculate the area of the colony by putting the radius length into the formula for the area of a circle. This gives us area equals pi multiplied by 2 millimeters squared, which approximately equals 3.14 multiplied by 4 millimeters squared dot. This results in an area of approximately 12.56 millimeters squared. Now let's look at calculating the area of zones of inhibition. When testing the effect of antibiotics or disinfectants, you will often see a clear area around the discs on an agar plate called the zone of inhibition. This is where bacteria have been inhibited or killed. To find the size of this zone, you also use the formula for the area of a circle. Area equals pi r squared. Let's take a look at an example. If the diameter of the zone of inhibition is 10 millimeters, what is the area of the zone of inhibition? If the diameter of the zone of inhibition is 10 millimeters, we can calculate the radius by dividing the diameter by 2. In this case, the radius is 10 millimeters divided by 2, which gives us 5 millimeters. Next, we can use the radius length to calculate the area using the formula for the area of a circle. In this case, area equals pi multiplied by 5 squared, which approximately equals 3.14 multiplied by 25 millimeters squared. This gives us a total area of approximately 78.5 millimeters squared. Now let's look at how we can estimate the number of bacteria in a population. To understand bacterial growth, it's important to calculate how the number of bacteria in a population changes over time. Bacteria typically divide by binary fission, meaning each bacterium splits into 2. Given the mean division time, you can estimate the bacterial population using the formula. Number of bacteria at end equals number of bacteria at beginning multiplied by 2 to the power of number of divisions. Let's break down how to estimate a bacteria population. Firstly, we need to note the time period for which the bacteria have been left to grow. Next, we need to find the total number of divisions that have occurred. The formula for this is the total time divided by the mean division time. Finally, apply the formula for the total number of bacteria at the end. This is the initial number of bacteria multiplied by 2, raised to the power of the number of divisions. Now that we understand the step-by-step process, let's go through an example together. If you start with 10 bacteria and the mean division time is 20 minutes, how would we find the number of bacteria after 1 hour? Step 1 is to identify the time period for which the bacteria have been left to grow. In our case, this is 1 hour, which is 60 minutes. Secondly, we need to calculate the number of divisions. To do this, we divide the total time of 60 minutes by the mean division time of 20 minutes to give us a total of the 3 divisions. Next, we need to calculate the estimated number of bacteria at the end. To do this, we apply the formula of the number of bacteria at the end equals the number of bacteria at the beginning multiplied by 2 to the power of the number of divisions. In this case, we need to multiply 10 by 2 to the power of 3. This gives us a total of 80 bacteria at the end. It is important to note that if the number is very large, you may need to express it in standard form. We will cover this in our future lesson on magnitude and standard form. Now, let's look at some practice questions. Question 1. A bacterial colony has a diameter of 6 millimeters. Calculate the cross-sectional area of this bacterial colony. Show you're working. Pause here to have a go. Let's take a look at the answer. Firstly, we need to calculate the radius of the colony. To do this, we must identify the diameter of the bacterial colony. This is given in the question as 6 millimeters. Now, we can calculate the radius by dividing the diameter by 2, which gives us 3 millimeters. Next, we can calculate the area of the colony by applying the formula for the area of a circle. Area equals pi r squared. When we put in the radius length of 3 millimeters, we get a total cross-sectional area of 38.2 millimeters squared. Let's take a look at a second question. The diameter of the zone of inhibition around an antibiotic disc is 14 millimeters. Calculate the area of the zone of inhibition. Show you're working. Pause here to have a go. Now let's go through the answer. First, we need to calculate the radius. To do this, we need to divide the diameter, which the question identifies as 14 millimeters, by 2. This gives us a radius of 7 millimeters. Next, let's apply the formula for the area of a circle. Area equals pi r squared to calculate the area of the zone of inhibition. When we input the radius value of 7 millimeters, we get a total cross-sectional area of approximately 153.86 millimeters squared. Let's look at our third and final question. If you start with 5 bacteria and the mean division time is 10 minutes, calculate the number of bacteria after 2 hours. Show you're working. Pause here to have a go. Now let's go through the answer. Firstly, we need to identify the number of divisions that occur. To do this, we need to identify the time period the bacteria have been left to grow and the mean division time. The question notes that the total time is 2 hours, which is 120 minutes, and the mean division time is 10 minutes. Using this information, we can find the total number of divisions by dividing the total time by the mean division time. This calculation gives the total number of divisions as 12. Next, we need to apply the formula to calculate the number of bacteria at the end of 2 hours. This is the initial number of bacteria multiplied by 2 to the power of the number of divisions. For this question, this is 5 multiplied by 2 to the power of 12, which gives us a total number of bacteria at 20,480. So, the total number of bacteria is 20,480, or 2.048 times 10 to the power of 4 in standard form. In conclusion, measuring and understanding bacterial growth involves calculating the area of bacterial colonies using the formula for the area of a circle. determining the zone of inhibition size to assess the effectiveness of antibiotics or disinfectants, and estimating the number of bacteria over time, given their mean division time and applying the correct formula. These calculations are essential for microbiologists to analyse and interpret bacterial growth and the effects of treatments accurately. Mastery of these techniques provides fundamental insights into bacterial growth, crucial for fields such as medicine, biotechnology, and environmental science.
Watch the rest of the GCSE biology course at Sophos Education.